In today's lecture, we are going to study chapter 7, which is called slope stability. Slope stability, from the name, it is a slope. What is a slope? A slope is a ramp connecting between two lands with different levels. One high level, one low level. So if I make a slope in between, then this ramp will be a slope. I have to check that this slope is stable, because maybe I constructed very, very steep to the extent that it would fall or it would reach failure. So I have to study the stability of the slope to ensure that it is safe, and we will see picture of some slopes that are not safe or were not safe and they failed. In this lecture, we will need the information that we have studied in chapter 6, which is direct shear test, which is also based on the shear strength of the soil. So I will need to all my information about the shear strength of the soil, because this is what I will apply in the slope, the stability of slope. So definitions. What is slope stability? Slope stability refers to the stresses soil or rock slope can carry without sliding or collapsing. If I have a slope or ramp, then what is the amount of load that this slope can carry without any problem? Because there may be loads on the slope. It's not the own weight of the slope only that I need to study. No, I need to study also the loads on this. Maybe you have cars going up and down this slope, so it's a load. So you have to take it into consideration. Maybe there are buildings on top of the slope. These are also loads that you have to consider. This is a crucial factor in planning, design, and construction of any engineering project, whether it's a bridge, dam, embankment, road, or structure. Civil and geotechnical engineers must account for any slope, whether it is man-made or natural, because we said an example of a resort on the beach, and I need to make steps or slopes. I will make these slopes, I will construct them, but sometimes the slope is already existing, or I drill or excavate a piece of land and I leave a slope existing. So I did not construct it. It was constructed from before, and I'm just using it and checking its stability. And they must also account for potential exogenous factors, which means the factors coming from outside, capable of triggering a major ground shift or a major ground slide. These forces or these factors are external factors, because, as I said, it's not only the own weight of the slope. No, there are many other factors. Suppose you have erosion, slope, and it is affected by rainfall, and this rainfall will induce erosion for this slope. Precipitation, water coming and particles precipitating on this slope, so the dimensions of the slopes will change. Snowfall, the effect of snow, effect of earthquake, effects of volcanoes, human activities, maybe excavation, backfilling. All of these factors affect my slope, and I have to study. Now we have to check what some of these slopes. If you try to concentrate in this photo, you will find that this is mainly a sloped area, and you have a road here. This road was continuing like this. It was going here. But suddenly, this portion of the slope slided down, and the road failed. there is a pipe here, or maybe this is the handrail, I don't know, but it is something, it shows that this part of the road was here and then it failed. All of these are examples. This is a slope, this is the shape of the normal slope. For some reason, this part of the slope failed. This is a road, but also, and this road is on a slope. Also part of the road failed. Here is a building that was built next to the edge of a cliff or a high area, and then it's failed, and the part of the building is now hanging in the air. So all of these are examples of slope stability failures. Excavation technique. If I want to make an excavation in the ground, it's either that I excavate vertically, and this is really it needs some interference from my side, how to keep the edge of the excavation standing. Maybe I would put a wall to carry this the side of the excavation, or I'm just drilling. Say I need to put this pipeline in the desert. The land is opened, so I will just drill, and I will keep the side slopes sloping like this. This is what I mean by slope stability. This slope here is stable, because after drilling, this is what it reached. But maybe if it rains, it would fail, because it was stable without the effect of water, without the effect of rain. Maybe if a car comes and stands next to the edge of the slope, it would fail. Why? Because it was stable without the effect of external force. But once you have external force, it will reach failure. So how can I manage this? In case of this project in the desert, I don't care, because it's just a temporary period. I will just put my pipe and then backfill on top of it, and everything will return back to normal. But if this slope is constructed to stay, then I have to check it. I have to check it that it would not be affected by rainfall, it would not be affected by earthquakes, it would not be affected by loads from any external forces on top of it. So I have to check that it will stay as it is for lifetime. So this is what I should do. Types of slopes, as I said, there are two types of slopes. There are natural slopes, something like this photo. This is a slope. This is natural. We did not do anything. We just went there and we found this slope. Nobody constructed it. But if you look at this is man-made. They use this slope to help in collecting water behind the slope, and maybe constructing a road on top of this slope. So it is something like a small dike to use for storing water, and use the top of it as a road. So this is a man-made slope. Of course, for you should know what is the very well known for us, very well known man-made slope is the high dam. The high dam is a slope. It's a dam, but it is really a man-made slope. This is the high dam. This is where we store the water in this side, and this is the upstream of the river Nile. So what happens? They constructed this embankment, which is double slopes, one slope from one side and one slope from the other side. They constructed this here, crossing the river Nile, to prevent water from passing to the north. That's so this is the south, this is the direction of the south, this is the direction of the north, and water is prevented from passing here. But they only let at this location few passages so that they can control some water from one side to go to the other side. Why do we do this? Because the river Nile has to keep flowing. There are ships going in the Nile. I cannot just store the water and no water goes to the upstream. No, I should let controlled amount to pass. So in this type of dams, it's not full blockage. It is complete blockage with openings. So and they are controlled. I can open this hole or close it as much as I need. So this is the very well-known high dam. These are all, if you go to the places, farms and cultivated areas, you will find that there are channels. These channels, mostly they are man-made. They are not natural. We construct these channels so that we would carry water from one place to the other. So what is important for me now is what we call modes of failure. How this slope would fail. Imagine that this is a slope. Here is the high area or the high land. Here is the low land, and this was a slope like this here. Of course, this is the shape during failure, but before failure, this wedge was on top here, on top of at this point. In engineering problems, to solve a problem, you have first to assume what will be the shape of the failure. Of course, we have seen lots of failures, something like these photos. These are failures. These are shapes of failures. So if I want to study the stability of this slope, I have to keep in mind what was the shape of the failure to study the stresses that would happen at the interface between the part that will fail and the remaining part. I have to study these stresses or these forces, and once I know them, then I will know what is the force that would cause failure. So to study a problem, I have to expect what is the shape of the failure. If I have a slope like this, then say I assume that the failure will be on this line. This line will slide and this portion, this wedge, will slide. In this case, to study this, to know what is the forces, I have from my knowledge of shear strength, how to calculate the shear strength of soil. So I can calculate the shear strength on this line. If I calculate the shear strength of this line, it means that the load of this wedge was more than the shear strength of the soil at this line. So failure happens. So it means that you have first to assume the shape of failure, then to calculate the forces and to check this case. But maybe this was not the failure case. Maybe the failure case is bigger. I mean that imagine that you have a line here like this, a line parallel to this line, but it is a little bit below. How can I judge which one is the failure? I will check what is causing failure, the load of this wedge. What is preventing failure? It's the friction all over this side. So I calculate the load of this wedge and I compare it to the friction at this wedge, and I calculate a number, and then study another case, go a little bit below. The value of the load will increase. And the value also of the stress, the shearing stress that will carry the load will increase also. So I will check this case and I will check this case and we'll see which one is the critical. Maybe when I increase the load, the sheared area increased sharply, so it is not the case. This is not the failure case. Maybe the failure case is a smaller case on top. Maybe it is a small portion that will fail. Anyway, I'm just giving you an introduction. Why I will study now planes of failure or modes of failure, because according to these modes of failure, I will later study each case of failure, what are the forces causing failure and what are the forces resisting failure, calculate the factor of safety. If I have something pushing me to fall with a force of X and something preventing me from falling with a force of Y, so what is my factor of safety? It is Y divided by X. Y is the force that is preventing me from falling. Imagine that I'm standing, you are pushing me with a force X, and your friend is helping me not to fall with a force Y. If Y is stronger than X, then I am not going to fall, because the person who is keeping me in place is stronger. But if the opposite happens, it will be a problem. So in this case, I will ask you, what is my factor of safety? My factor of safety would be the strength of the person who is keeping me in place divided by the strength of the person who is pushing me to fall. If the number is 1, it means that they both are pushing me and I'm on the brink of failure. I may fall anytime. If any one of them feels a little bit tired, I will fall, or I will not fall. It depends on who is the person who is going to be stronger than the other. But this is what I mean, that in any case, in slope stability or in many other cases, to study it, we have first to assume a shape for the failure, see what are the forces that are pushing this shape to fall or to fail, and what are the forces that are keeping this shape in place. Take the factor of safety. The least factor of safety is the critical section where failure might happen first. Usually, if I find a factor of safety of less than 1, it means that this is it is already a failure. But it is standing just by the will of God. It's not. But by calculation, it's a failure. So here, plane of failure. Plane of failure means where the failure is going to happen. Is it going to happen at this location or below? Is it straight line? Is it curved? Is it 2 lines? I don't know. I have to assume. So it is, first of all, the plane of failure. Is it infinite slope or finite slope? Infinite slope, I will show you something. This case of loading, is it a finite failure or infinite failure? What do I mean by finite or infinite? Finite means the failure is local. I have a local failure in an area. Infinite failure means a whole stretch is going to fall, because all of this is my slope. But the failure happened from here to there only. So this is finite failure. It's located in this. But if I look at this may be an infinite failure. Why? Because the width of the failure is very big compared to my site. I'm seeing a very big stretch that that has reached failure. So in this case, I may consider this infinite failure. Of course, not infinite means to the end of the world, but infinite here means, say, 1 kilo, 500 meters, something like this. But finite means a local failure, 20 meters, 30 meters, 40 meters. This is a local failure or infinite failure. So here in this case, either I have, where is it? This one? It's either an infinite slope occur in case of existing weak soil above strong soil, causing the weak soil to slide over the strong soil. Finite slope occurs in case of existing weak soil above rock. Actually, I don't want to stick to these definitions. I want to stick to what I've just said. It means that infinite, regardless of the case, infinite means that it is a very long stretch. Finite means that it is a local failure. So what I see here in this drawing, it's infinite. Why it is infinite? Because it starts from the end of the section that I sketched till the end, till the other end. So it starts from the end to the end. There is no portion of this slope that is still standing. All of it failed. So it is, in this case, we can consider it infinite, because all of the slopes, any slope similar to this one will fail. This is considering the size of the plane of failure. Another thing, the curvature. Is it curved or straight line? And if it is curved, is it circular or is it other curved shape? So for curved failure, it is either circular failure or non-circular failure, any shape. So in case of non-circular failure, it is more accurate study. In more accurate study, the collapsed surface is approximately a long spiral curve instead of part of a circle. This is the logic, because the exception is to have a circle. But who said, take a look at this. If I say that this will be the portion of the slope that will fail, this is my original slope. It is standing like this. Maybe in one case of loading, this portion of the slope will slide down. Who said that this curve should be a circle? Exceptionally, it would be a circle. The general case, it is a curve with different radiuses. So this is what do we mean by circular and non-circular failures. For a non-circular or circular failure, we have also many types of failures. Either we consider that part of the slope will fail. This is the full slope. I will just take portion of it and this portion will fall. Or I can consider that the failure will reach the toe. All of this will fall. Or base failure. It means that it is not only the failure will reach this point, all of what is above will fall. No, there will be a circle that will slide, will take part of the buildings below or part of the land below with it. So this is a base failure. If I tell you from a photo which one applies to it, this one, would you consider this a slope failure, or a toe failure, or a base failure? Maybe it is not a base failure. First of all, it is not this case. It is not slope failure, because if it is a slope failure, then I will see part of the slope still standing, but in my case here, nothing is standing here, because my failures start from this point and end at this point. All over this stretch, I don't see any part of the slope standing in place. So it means that it is not failure in the edge. It's not slope failure. It may be toe failure, and it may be base failure, but the photo is not clear, because I cannot judge really from this location where is the end of the failure. But it seems to me that it is more or less like this case, which is base failure, because I see here some soil gathered on top. So maybe it is because the base failure, or maybe it is just the toe failure, and you have here this soil, part of it is here. So it may be base, it may be toe. People who go there see for themselves can define this slope. Is it a toe failure or a base failure? Usually, and this is the problem, none of these happens. It's a combination of everything. Part of the slope is slope failure, and the other is toe failure, and the other is base failure, and so on. And it is not always circular, part straight line, part polynomial, everything happening together. That's why when you look at something like this, you really cannot define first where is the area that failed. It does not have any shape. It's just a random shape. How it failed. So I have to assume. This is what we usually, if say from this photo, I can say, I can consider it a base failure. And I would check a drawing with high land and low land and a slope, and I draw a base case, something like this. I will draw something like this. And I will check the stability of this. How can I check the stability of this? Similar to what I just said. To check the stability, you have to do many things. First of all, assume the shape of failure. This is the assumed shape of failure. I need to check, is it stable or not stable? Then I have to check all the forces causing failure and compare it to all the forces causing stability. And I compare both together. If the stability is more, then it is stable. If the driving force are more, then it is a failure case. So this is what we usually do. What about the normal case? It is composite failure. It is composed of all types, as you see here. Part is curved, part is flat. Part here maybe in the other direction. You will find a combination of all things happening together. How can I solve it? I cannot solve it, because I do not have an equation or a program or a method for solving any shape in the world. I have to approximate it to known shapes so that I can study. So suppose I give you something like this, and you don't have a method to study this, then you can assume, say, okay, I will assume that this is a toe failure, a base failure, and I will draw a curved line from here up till this point, and I will study these cases. Maybe I would study a small one, a bigger one, and check which one has a smaller factor of safety and so on. So our analysis is always approximation. It's not the real case or the real life. Forces that causes slope failure. As we said, we have two types of forces. Driving forces, or the forces that cause slope failure. The example that I just told you, if I am, if you are standing and if your friend is pushing you to fall and another one is pushing or keeping you in place, then I have, if I want to study your stability, I have to check your friend's power to check if he is stronger than the other friend that is keeping you in place. If I find that the person who is pushing you is stronger, then you will definitely fall. But if the person who is pushing you is weaker, then you will stay in place. So this is exactly what we are going to do. We are going to study what are the forces that cause slope failure. If I have this slope or this slope, what forces driving this slope to move? And what forces preventing this slope from motion? Okay, so we will go. What are the forces causing failure? Weight of the wedge, seepage force of water, earthquake, surcharge. So these are the four forces, the four main forces causing the slope to fall. And there is another way of classifying them. We will study them later. But let's discuss these four things. The weight of the wedge. If I have this area that wants to fall, if the weight is high, then it will slide more. Imagine a child playing on what do you call in English, الزحليقة. Anyway, it's a slider or something like this. And if small child is on top, he may sit and he does not move. Because the friction between him and the surface is bigger than his weight. But if bigger person or with person with more weight is his place, he will slide very quickly. Why? Because the driving force, which is the own weight of the person, is more. So it is more or less similar. Of course, here I am speaking about the own weight of the soil itself. But increasing the own weight over here will increase the force, the driving force. Seepage of water. If I have water here and the water is going down, so it is pushing the soil in the same direction of motion. So it will help in instability of this portion. Earthquake. Any earthquake can cause failure in any building without discussion. So earthquake can cause failure. Surcharge weight. If I come to this slope and imagine that you build a building on top of here, this building will help the slope to fall more. Why? Because you are adding weight to the own weight of the portion that is going to fall. So you have any surcharge in this area will add to the forces driving the slope to fall. Here we say factors leading to instability are classified as factors causing increased stress on slope, factors causing reduction of strength of soil. It means that factors causing increased stress on the slope are these four factors. These four factors can help to increase the load on the slope. But there is another thing which is, instead of increasing the forces here, no, I'm just going to reduce the strength of the soil. We will come back to our example. You have somebody, you are standing, your friend is pushing you, and your other friend is preventing you from falling. If somebody came to your friend who is preventing you from falling and give him a kick in the leg, he will be weaker to help you. So he will fall and you will also fall. So this is what we mean by factors causing reduction in the strength of the soil. What is keeping the soil in place is its internal strength. The soil has C and phi, and it can carry, according to our lecture of shear strength, we know that according to the C and the phi, the soil can carry an amount of shear strength. If I come and do something to the soil, so I have a reduced shear strength, it means that I will not. So the person who is keeping you in place is the shear strength of the soil. If this shear strength is weakened, then you will probably fall. By? Yes, anything that would be added to the soil and affect the soil and decrease its whatever is the parameters of this soil, then it will reduce this. Usually with chemicals, it is, in theory, yes, but how come chemicals will reach maybe 50 meters below ground? It is very difficult. But if it reached this location, these chemicals may be something that would add strength. If you put something, chemicals that would add strength, it's okay. If you put something that would decrease the strength, then it will reduce the strength of the soil.
I was looking at the land itself would have like sulfur, like natural.
If the soil itself is layered and each layer has a specific parameters, of course each layer will have a different C and phi. If you have a very weak layer, then the C and phi will be very weak, and so on. So this we will study when we come to the example of how to calculate the stability of the slope. We will take an example and we will draw a slope and we will calculate what are the driving forces and what are the resisting forces, and we will calculate the factor of safety. And we can say in this case, suppose that the land is not, or the soil is not one layer. Suppose it is multi-layer and each layer has its own C and phi. Then in this case I will have to calculate the C and phi of each layer and introduce it in my calculation. So of course if you have weak layers, then it will affect the stability. Factor causing increased stress on slopes, increased unit weight. If I increase the unit weight of the soil, then the weight will increase. If I add external load, the external load, it means that the weight will increase. If I make the slope steeper, this will induce more driving force on the slope. So these three things increases the stresses on the slope. The other factors causing reduction in soil strength, cyclic loading. This cyclic loading may be earthquake. If you have an earthquake, then it would affect the soil. By absorption of water. If water came in this slope, so water will affect the soil properties. Increasing the pore pressure. If the pore pressure for some reason increased, we said that increasing the pore pressure is very bad. You remember why we said that increasing the pore pressure is bad? We said that you can stand on top of a bowl full of water, so water can carry, but it has to be prevented from shearing, from being sheared. Because can you stand on top of water? No. If I'm standing on top of water, I cannot. I will just penetrate the water because water cannot carry any shear strength. But if I came to a bowl, a very big bowl, and fill it with water, I can go on top of it and I can stand or I can lie down. How come I do this? Because I am preventing the water inside from being able to be sheared. So prevent shear, you will get strength. So in case of increasing the pore water pressure, it means that there is pore water pressure and it can carry vertical force. But if I affect this area with shearing force, water cannot carry shear. So it is a reduction in the total stress of the slope. So if pore water pressure increases, then shearing forces will be possible, or shearing of this slope will be possible, and this is one of the factors causing reduction in the strength of the soil. Factor of safety. As we said previously, the example of you standing and somebody, a friend of you, is pushing you and another one keeping you in place, you should have a factor of safety. What is this factor of safety? The strength of the friend that is keeping you in place over the strength of the person who is pushing you. This is your factor of safety. If the person who is keeping you in place is double as much the person who is pushing you, then your factor of safety is 2. Because 2 persons can push you and you will not fall. So it means that your factor of safety is 2, and so on. So factor of safety is what? Is the person preventing you from falling. In soil, it is the shear strength of the soil. What is the ability of this soil to carry shear? We said that soil fails by shear. So what is the ability of soil to carry shear? So it is the shear strength of the soil. How much strength can the soil carry before going to failure? So this is the force that you can carry, or the person who is preventing you from falling. This is the first case. The second case, or the denominator here, is the shear stress. The shear stress is the stress causing you to fall, or causing the slope to fail. What is this value? It is the value of, it is the power of your friend who is pushing you. So it is the stresses acting on the soil. So if I have a slope, and this slope from inside, it can carry a certain amount of load. I don't know it, I will calculate it. But this slope can carry a certain amount. If I go and stand on a ground, this ground can carry a certain amount, and I don't know. If I go and stand on top of it, I will stay in place. If I go away and somebody heavier than me stand in my place, he may penetrate the soil. So it's failure for the soil. Why? Because the force that this person exerted on the soil is more than the amount that the soil can carry. So this is exactly what we are doing, but instead of speaking about person standing vertically on the soil, no, it is a slope where this amount of soil wants to fail and the soil is keeping it back in place. So it is actually, if you look here, this amount wants to go down, and the friction and the cohesion along this line prevent this from falling. Can you follow me here? Let's start from here. This small portion, it wants to fail, to fall. I will tell you calculate the factor of safety. You will calculate the forces that is driving this wedge to slide. It is mainly the own weight of this wedge. And you will tell me that the force that is pushing this slope is because of this load. What is preventing it from falling? The friction along this line. So I will calculate the friction along this line. When I put the friction along this line, friction and cohesion along the, because something due to phi and something due to c. I will calculate whatever is here and divided by the value of the force that is pushing, which is the own weight, I will get the factor of safety of this slope. Suppose I get a factor of safety of 2, then this slope is okay. And I will go to this case. I will study this area and get the load that is causing the failure, and I will study the shear and cohesion along this new line, and I will compare them together. Suppose I get a factor of safety of 1.5. So it is still less. So the possibility of this to fail is more than this, because here it was 2, here it was, in this example that I'm speaking about, it was 1.5. And then I go to this one, I will calculate the weight of this new portion, and I will calculate the shear and the phi stresses along this line, and I get something less than 1, suppose 0.8. Then you will tell me that this is the failure case, this is not the failure case, and this is not the failure case, this is the failure case. By the way, it does not mean that always it will be the base failure, no. Maybe this is 0.9, this is 2, and this is 3. So this is the case where it will fall. It depends. So this is exactly what we are studying here. Where is it? Factor of safety. Shear strength is the portion of the load that is inherited inside the soil. It is the force that the soil can carry. If I tell you how much weight can you carry, when you go to the gym, you can, how much weight can you, suppose you are a weight lifter, and you can tell me I can carry 100 kilos. So your capacity is 100 kilos. If I go and tell you carry 110, you will carry 110 and you will fall down. So but if you carry 50, then you will carry it very lightly, and you will still have a factor of safety of 2. You can carry more. This is exact. Shear strength is the ability of soil to prevent the failure of the slope. Shear stress is the stress on the slope due to external forces and internal forces, of course, due to any forces. So any forces that is driving the slope to fail, it will be the shear stresses. So it is tau divided by S, and we come back to the equation that we have studied in the shear strength of soil. There was an equation that tau is sigma n, which is the normal stress, multiplied by tan phi plus c. So now we have our factor of safety is the relation between the shear strength and the shear stresses. Shear strengths are the stresses on the failure surface. So first of all, to go to this factor of safety, you have to do something. You have to assume what is the shape of the failure. Because if I assume this shape, I will get a factor of safety. If I assume this shape, I will get another factor of safety. Here it's a third factor of safety, and so on. There are millions of factor of safeties. So which one I will follow? I need the minimum factor of safety. So how can I do this? Actually, to solve this problem accurately, usually the computer program studies lots of cases. And there are many ways for studying these lots of cases, so that finally he will tell you, for this slope, I have studied 100 cases, and the minimum factor of safety was the factor of safety of, suppose, this assumption. So you know that this assumption, this one, is the assumption that will cause the failure, or the one with the minimum factor of safety. So first of all, you have to assume that if you want to calculate the factor of safety, you have to assume which shape of failure you are going to follow. Is it this one, or this one, or this one, or any other type? Maybe it's not circular, maybe it is a straight line, maybe it is curved, whatever you are going to assume. Then once you assume, then you will have to calculate the shear stresses, which are the stresses on the failure. You assume the failure surface. Calculate the shear stresses due to the forces that are driving this slope to fail. So you have to calculate the stresses acting on this failure surface, and to calculate the shear strength of this failure surface. What is the strength of this failure surface? If I come to this one, if I tell you here, what is the forces that is acting, that is causing shear stresses? It's the own weight of this slope. It's any external load on top here. It's the water if it is moving, seeping here. All these forces, I will get its effect, and I will tell you that there is a stress of a specific value acting on this plane. This is the first part. The second part, I will take this, and I know the C and phi of the soil. I will substitute in the equation of the shear strength, and I will get the stresses, the shearing stresses that the soil can carry along this line. Once I get these stresses, then this is what is keeping me from falling, or this is what is keeping the slope from falling. I will take this value, divide it by the value of the forces that is causing the failure, to get the factor of safety. So this is exactly what we are going, what is here. Actually, this is factor of safety with respect to shear strength. There are many factors of safety. The main thing is the factor of safety due to the shear strength. But there is also, in this case, a factor of safety with respect to moment. What does it mean by factor of safety with respect to moment? If I have, suppose this one. This block wants to slide along this circular line. So imagine that you have the center of this circle at this point. So this load, if I have a load here, this load multiplied by the arm of this center, it will give you the moment. So this moment is the moment driving. There is another moment, is the moment due to friction, which is the moment along this line. It's the frictional force between this part and this part. And this moment is acting in the opposite direction, because if you want to slide down the hill, your body is, or the soil is preventing you by a force that is going up the hill to prevent you from falling. If I have something and I put it on a sloping surface, there is force pushing it down. What is preventing it? Anything to prevent it should be an equal and opposite force. What is this equal and opposite force? It is the force due to the friction between the body and the material. So if this bulk wants to fail or want to slide, then there is a force here along this line. This force along this line prevents your this big body from falling. So it is a force in the opposite direction. If this wants to fall in this direction, then this along this line is in the opposite direction, it's going up. So there is a moment also, because if you have force in one direction, a force in the other direction, take the point, the center where this failure will happen, multiply the force by the arm of the force in both cases to get the factor of safety with respect to moment. So this is the factor of safety with respect to shear, this is what we said. Then there is something called the factor of safety with respect to moment. We are going to discuss this when we come to the example. Consider this is just an introduction to the real case, but but it is a very big, long introduction, because you have to understand everything to be able to later to judge each point when we come to discuss it. I will show you something like this. We are going to study forces, and this is the point where the slope wants to rotate. So this force multiplied by the arm of it, and this force multiplied by the arm of it, and so on. We will come into examples. So this is something, this is important, but to understand this, we needed to study all what we have studied so far. We will stop at this location, and we will continue next time, inshallah. Thank you, and see you next week.